Welcome to another video in the series about the C7000 compiler. This video introduces host emulation, which is a way to run code written for a C7000 DSP on a hosted system such as a Windows laptop or a Linux box. My name is George Mock and I'm your guide. What is the motivation behind host emulation? Well, what if you could run C or C++ code written for a C7000 DSP on a hosted system? You know, like a Windows laptop, a Linux box. Well, then you could take advantage of hosted system debug features. And then you can rebuild it for your C7000 DSP. Well, hold on a second. What about the C7000 compiler specific features, like, say, vectors, intrinsics like select and so on? What about those? What happens? Well, code from host emulation implements those C7X features in standard C++. Throughout this presentation, the abbreviation HE stands for host emulation. So host emulation is often the first way C7X code gets executed. Please consider this simple example. It's a C++ file with these source lines in it. It's got one vector and it prints that vector out. These are the build commands for building this for a typical Linux system. So this first command creates a variable C7X_root to point to the full path of wherever the C7000 compiler is installed. And then that command compiles it. This command links it, creating the executable ex1, and this is what it looks like when you run it. It prints out the contents of that vector, 1, 2, 3, 4. Okay, so the next part of this presentation is going to walk through this example one small bit at a time. First, let's look at the source code of the example. Notice that it is a C++ source file, which is to say it's not a C source file. Host emulation is implemented in C++ 14, so it has to be compiled to C++. Depending on how your host compiler works, there are multiple ways to go about getting that to happen. The most typical one is to use the file extension .cpp. The next detail to look over is it includes the header file c7x.h. Okay, so all files that use C7X specific features, such as vectors, as in our example, must include the header file c7x.h. That is included as part of the HE package. All right. The next source line to examine is this one. This creates a vector. The name of the vector is vec i4. The i4 part is a way of signifying that it is a vector of 4 integers, and this is what it looks like to initialize it to the values 1, 2, 3, 4. Okay. And then this line prints out the contents of the vector. Now what's notable here is that this is a host emulation only feature. Okay, you can't actually do this .print operation when you're running on a C7000 DSP. We'll be talking about this a bit more later. Next, let's look at the compile options that are used when building on a Linux system with a G++ compiler. The first option to look at is --std, stands for standard equals C++ 14. You need to use that because the HE implementation relies on C++ 14 language features. The next G++ option to use is -f, no strict aliasing, and that is because the HE implementation of vectors relies on differing types. And this option tells the compiler don't use certain optimizations that are related to these differing types. If those optimizations were to be used, that could cause incorrect results. Obviously, we don't want that. The next option is this -i. This is how you add to the list of directories that the compiler, the G++ compiler, uses to find header files. So in this specific case, we want the G++ compiler to find the header file c7x.h. Now the C7100 directory here, this is an important detail. It has to match the C7000 DSP you are using. At the time of this recording, this is the full list of what is available. Expect that list to grow over time and for other directories to appear here. And again, as you're using these, future DSPs released in the future, you will need to match that directory name with the DSP that you're ultimately targeting. Next, let's look at the options used when linking with the G++ compiler for a Linux system. The first option to consider is -L. That's the option you use to tell the linker, add this directory to the list of places that are searched for libraries. And then -l is how you tell the linker, add this library to the set of things that are linked against. So you write it like this, and then the convention with the G++ linker is that it adds lib to the front, .a to the end, and so it ultimately forms this full library name here. Now the C7100, that is an important detail. Just like with the header files, it needs to match the DSP that you are ultimately targeting. This is the full list that's available now, and expect that list to grow longer in the future. Now that we've walked through all the various details of the example, I think it would be helpful to take another look at the entire example. Here's the source code, some C++ source code, creates a vector, prints it out. These are the build commands on a typical Linux system using the G++ compiler. Okay, and then this is what it looks like to run it. Earlier in the presentation, I talked about how this source line is not valid when you're running on a C7000 DSP, particularly the .print operation. That's not valid code, which raises the question, well, what might you do to change it? How else could you handle it? Well, here's one way to go about it. There is a preprocessor symbol, predefined, this one right here, that you can use to say, do it this way when building for host emulation, do it this other way when building for running on a C7000 DSP. The preprocessor symbol, C7X host EM, it's defined in C7X.h from the HE header files, but not defined in C7X.h from the standard runtime support header files that come with, all the other runtime support that's part of the C7000 compiler installation. There is an online manual just for host emulation, and I'm going to show you how to get to it. So search on C7000 compiler, and this first result is the page you go to, so click on that. And this is the home page for the C7000 compiler. Here's how you get to all of the related documentation. And check it out, it's the first one, Host Emulation User's Guide. That's the one you want. Here it is. I will close this video with two references. The first one we just saw, the home page for the C7000 compiler. As you saw, you can search for it, or maybe you like to type in long web addresses like that one. If that works for you. Here's where you can download the compiler, access the manual, including the host emulation manual, and more. The second reference is to e2e.ti.com. This is where you can go to ask questions about any TI product, including the C7000 compiler. If that question is related to the compiler or a related tool, it will be answered by me. Thank you for watching this video in the series about the C7000 compiler.